So we'll officially start recording. I have your folder of stuff here. What would you like open?
I think just the Word document.
The Word document. You got it. So we have the ordinal example to finish then, and then we get to talk about counts. Hooray! And my computer is feeling very slow today, much like my brain. I think we're all on the same page here. You can do it. Go, go. All right, there we go. And it's nice and big.
Yay.
All right, knock yourself out.
Thank you.
Thank you.
All right.
Make sure I'm recording. Sorry. I don't remember if I turned it on or not. Yeah, I am. Okay, we're good. All right,
Great.
You were.
Excellent. Well, I'm excited to finish out this example. So as a quick refresher, we are looking at first-generation college students who started in the fall of 2022 and predicting their belonging using a measure of belonging that has 3 categories, which are low, medium, and high. And we left off on the empty means model. Which is down here. And so as a quick reminder, because it's an empty means model, we don't have any predictors in the model. So I am using the go logit2 command. And so these are intercepts. And so this is the intercept for predicting higher than low belonging. And then this is the intercept for predicting higher than some belonging. Were there any questions from this from last time? Sorry, I have a smudge on my glasses. Okay. So then we also have a few post-estimation commands to give us model fit information and our predicted probabilities. And these align with our descriptive statistics of folks who select the different categories. This is a lie. This is no longer an empty means model.
Yeah, you can only see it in front of people. That's the rule.
Well, now there's 2 errors I need to fix, because the other issue with this line is I thought I was doing a proportional odds model, but you might notice that the coefficient for first-gen Hawks actually differs across these, and that's because I did not specify PL in our command. So this model just adds first-gen Hawk participation. So that was the support program that first-generation students could participate in. And what do folks notice about the output here? It could be the sign of the predictors. It could be the significance of the predictors. What do folks notice? That's not my water.
I'll share if you need it, though. I'm always double-fisted in here. I noticed that belonging is spelled wrong.
Yes. Fair. Okay, cool. Yep.
Stata shortens your labels.
Yes. With a tilde. So it only shows a certain amount of characters, gives a tilde for the middle, and then shows you the last one. So yes, belonging is absolutely spelled wrong. What do folks notice about the significance of the first-gen Hawk predictor? Is it significant or is it not significant? Not, yes. So our p-values are greater than 0.05, so wah-wah. First-gen Hawk's participation does not significantly predict belonging, increase in the logit of belonging, either for low belonging here or some belonging here, higher than some belonging. But the model is predicting down, so the coefficients are negative, which means the logit would essentially decrease if folks participate compared to non-participation. So there is the potential that this could even be going in the wrong direction.
It made it worse.
Yeah. Yep. Which is interesting because some of the preliminary analyses and the curriculum for first-gen Hawks, they center like belonging and trying to find community within the first couple weeks. So it might be just an interesting, folks are more aware of it, and they're in a new space, so they're feeling a little bit uncomfortable, and not actually that they feel a lower sense of belonging. And actually, our qualitative methods suggest otherwise. So the reflection assignments that are at the end of the semester, every single student, and I think the fall 20 cohort, talked about how they found friendship or community through the program. So this is just a shout out that quant methods can do a lot. They can't do everything.
I'll pull in another explanation.
Yes?
People self-selected into this program. Perhaps they self-selected into a program to help them for reasons.
Yep. Maybe they're hoping that this program could give them
a sense of belonging.
I like that one. I like that one.
Well, whenever you don't have random assignment, right, it's hard to know what's what.
Yep. So as a quick reminder, everybody who applied to this program was allowed to participate. So folks essentially opt in. There is no decision or different things like that. So that's what Lisa's talking about in terms of a selection effect. Folks select into participation. Excellent. Okay, so here's an actual proportional odds model. Then we added a few other alternative explanations, essentially. So on campus represents whether or not folks lived on campus, coded as a 0 for off campus and a 1 for on campus. Home visits were the number of visits a student went home, leading up to where the survey was administered, which was very early in the semester. And then the time spent in student organizations. And I am treating both of these as quantitative predictors for kind of ease of interpretation. So again, we see that first gen Hawks is negative. It's still non-significant though. So when folks go from not participating to participating, the expected logit, when predicting higher than a low belonging, goes down by 0.18 is how I would interpret that. Do I have a volunteer to interpret the on-campus one for low belonging? Nope.
Scroll the mouse wheel with control. There you go.
I do like your mouse.
Spend $10 on it on Amazon.
Okay.
Yeah.
Do I have a volunteer to practice? Yeah?
Can you repeat how you interpreted the first one?
Absolutely, yes. So someone asked in the room to repeat the interpretation of the first one. So compared to folks who are not in first gen Hawks, those who are in first gen Hawks, when predicting greater than low belonging, their expected logit goes down by 0.18. So with this question, what's the 1 unit change in X?
Compared to students who lives off campus to on campus.
Yes. So the change is going from living off campus to living on campus. Absolutely. What is the expected outcome that we're predicting? Is it higher than low, or is it higher than some? Higher than low, yes, absolutely. Because we're in this part of the model, we're predicting higher than low. And then what's happening in terms of, is it increasing, decreasing, and by how much? Great, excellent job. So regarding home visits, we see that the expected logit is actually decreasing for each home visit that a student completes, I guess. And then time in student organizations is a positive predictor. So as students are spending more time, the expected logit when predicting higher than low is positive. And so collectively, these kind of results indicate that like maybe first-gen Hawks participation doesn't still matter in the story, but living on campus matters because there's potentially like easier like baked-in community, right? You've got resident assistants who might be hosting programs that are developing community within students. Home visits, you're off campus and you're not necessarily hanging out with people to create community here. And then time with student orgs, again, you're hanging out with people who share similar interests in terms of your student organization. Because this is a proportional odds model, that means that the interpretation for the low belonging, the coefficients are the same between whether or not we're predicting higher than low or higher than some. And so this is the same as this coefficient, this is the same as whoop, this one is the same as this, and so on and so forth. Any questions about this model? Great. I did create a pretty picture for this one. And this is predicting, this code comes from the example that Lisa provided. And we're examining the hours spent per week in student or community organizations, predicting higher than low belonging. And arguably in context, this submodel might be the most important one in terms of predicting it. I was also fighting with Stata, and I could not get it to give me the higher than some charts, essentially. So what we notice here is for folks who are not in first-gen Hawks, the switch between on and off campus, we see that when you move on campus relative to the blue line, the red line is higher, right, which fits with the model results that we saw above. And then if we come down here for folks who are in first-gen Hawks, we can talk about going from off campus being the green line and then on campus being the yellow line. So those distances are going to be equivalent in terms of the bump between on and off campus. Alternatively, we could talk about folks living on campus and then the change between first-gen Hawks or not. So that would be the red line here, folks who are not in first-gen Hawks versus folks who are in first-gen Hawks. So that's the difference between the red and yellow lines. So again, because we had a negative coefficient for first-gen Hawks participation, that's going to be bump the line down lower. And then the same thing with off-campus students with the blue and green line. In this model, this model is assuming that home visits are held constant because I didn't produce a margin for those things. And I just chose community or student organization because I thought it was more interesting. Any questions about the picture?
Nikki, I have a question. Actually, it is not. Oh, can I
No,
go?
you go ahead, Zora. There's a
Okay.
question in the room. You'll go first and she'll go second.
Okay, thank you. So it's not actually about the question about that picture, but I was thinking about the Lisa's comments that interpreting the results, I mean, so because there are chances that already students with low belonging is choosing this program to try to enhance their belonging. So I remember that you mentioned that one of the survey was designed to check in, the really first phase of the weeks. So if you have belonging measure in that time, then how about design the study like comparing like at the very beginning and then after treatment, things like that?
Yeah, that's a great question. I would love to have a estimate, like a questionnaire administered at the end of the semester. We essentially decided not to do that because we didn't want to burden our participants. So the data from this comes from Excelling at Iowa. All students have to take it within their first year seminar courses. And so we have like really high completion rates for this survey. And so we're just making use of data that we have available to us in order to inform like early steps kind of in the program and whatnot.
Okay, I mean, I was told that this study, the effectiveness of study of first-gen Hawks is still going on. So can't you at least implement that kind of like design to really see how effective the program is? Because I think that is the main purpose of the study originally.
Yeah, I do think that there was a preference to use secondary data, so avoid original data collection, both for our sake, in terms of it was me on this project and then my advisor. And so
Okay, yeah.
anytime I suggested it, he was like, yeah, we're not going to do that. I'm like, okay, great, you're the boss. Like,
I mean,
Yep.
it was really hard to use secondary data, I understand. Yeah. Thank
Yep.
you.
And I do think that like he was more interested in like the academic outcomes that we analyzed with this information. So that was, I feel like, his focus.
Mhm,
Partially
okay,
because this survey was in the middle or very early on in the first year. There's kind of some conflation effect of like the program has kind of already started. And so like this is also a reason why maybe this isn't the best measure in terms of trying to understand sense of belonging for first-gen Hawk students, because it is so like early in the intervention. So great questions. Yeah. What was the code for this? Yes, so the code up here is this. So Stata is really nice with its margins commands so that I can just put in what variables I want for different values. And then the way the syntax works is it's like start at this number, go up according to this interval until you hit this amount. So first-gen Hawks is literally just going to be a 0 and a 1. And then on campus, also a 0 and a 1. Time in student org, I think, ranged between like 1 and 7. Again, I'm treating it as a quantitative predictor, which for ease of interpretation, and I think this is actually more of an ordinal measure, but start at 1, go up by 2, and then stop at 5. The XB option is what is going to be the Y hat in probabilities.
Other way around.
Logits?
Yeah, you're in Logits.
Wow, I made so many mistakes in this. I'm up to 3 already.
See, do you know how I know that? If you scroll back down to the plot, are these lines straight or bendy?
Yeah.
That's how you know it's a logit plot.
Mm-hmm.
And also the very unhelpful y-axis label,
Yeah.
linear prediction. Duh. Yeah. Thanks, Stata. That's very helpful.
Yep. So then Stata takes all of these kind of numbers that they cycle, and then it cycles through all of the different values to get this output. And then I used margins plot, which is make a picture essentially. And so this is putting time and student organization on the x-axis. I turned off the confidence intervals because the bars very much overlap and whatnot because of the non-significance with first-gen Hawks. And so for ease of viewing a pretty picture with rainbow colors, I just turned them off. Great. Any other questions? I also estimated odds ratios instead of logits, and the difference between that line of code and this line of code is just OR in terms of estimating the models. Again, they're still proportional odds, so your coefficients are going to be the same. Oop, here, and here, and here, and so on. I did test a non-proportional odds model, and so that's essentially, are the slopes the same across submodels? And I think that time in student orgs was the only one that was significantly different. No. That's this table. There we go. This got close. That's why I said test, because I was like, I don't want this anymore. This says I don't need a non-proportional odd, so I'm just going to keep a proportional odds. But that is my example. Are there any final questions? Great. Well, thanks for letting me present.
Thank you. Yes. Ordinal regression in action. And I'm going to sit myself back down. No standing desks for me. I had too many jobs where I had to stand all day long, usually wearing a name tag. To me, a PhD means I've earned the right to sit the hell down at work. Am I right? Maybe not, but anywho. All right, switching gears then, actually.